Welcome to LeChatelier's principle. So this particular concept in chemistry is all about restoring equilibrium. The goal is to keep the concentration ratios of products to reactants the same. So the KEQ, which is products over reactants, of one set of conditions has to be equal to the products over reactants of the second set of conditions. The system will change to accommodate the surroundings. So here we have two reactants, A plus B, equal two products, C plus D. The KEQ is equal to the products over the reactants. If the concentration of A increases, then that causes the numerator in the fraction to increase, and thus the KEQ increases. So to counteract this, the reaction has to shift from left to right, thus increasing either C or D. If C or D increases, as the numerator is increasing, this will keep the ratio the same. In this particular example, we have A plus B, which are the products, both are gases, equal to C, which is the reactant, which is also a gas. If one or more of your components is a gas, the volume and pressure of the container affect what way the reaction shifts. If the volume of the container decreases, the reaction will shift to the side of the reaction that has less moles or atoms or contents of gas. So if the volume of the if the volume of the container were to decrease, the reaction would favor the side that has less moles or atoms or constituents of gas. So therefore, the reaction would shift to the right-hand side. If the pressure were to decrease, the reaction would favor the side of the reaction that has more moles or more atoms or components of gas. So the reaction would shift to the left from C to A and B. In the last example, we have an exothermic reaction where we are now incorporating temperature and heat into LeChatelier's principle. So we have A plus B becomes C plus D plus heat. Now, if your reaction is specified as endothermic or exothermic, the temperature of the surroundings will affect what way the reaction shifts. If your reaction is exothermic, the reaction will shift to the right if the temperature decreases. The reason being is because if the temperature decreases, the reaction will do everything it can to increase the temperature of the surroundings back up to where it was. As a result, it will favor the side of the reaction that produces heat to increase the surrounding temperature. The reaction will shift to the left if the temperature increases. If the temperature becomes too hot, the reaction will favor the side that does not produce heat and will suck up all of the heat to decrease the temperature. If you decrease the surrounding temperature, your reaction will shift to the side that produces heat to stabilize the environment.